Beneath the waves of our modern oceans swim creatures that defy imagination. Whales, intelligent, massive, and utterly magnificent, rule the seas as the largest animals ever to exist. But their story begins not in water, but on land, with hoofed mammals no bigger than house cats. In just 25 million years after the dinosaurs vanished, evolution transformed these terrestrial creatures into oceanic giants. Among them arose a predator so fearsome it hunted the largest prey the seas had ever known. This was Livyatan melvillei, a sperm whale armed with the biggest biting teeth in history. For 5 million years, it battled Megalodon for supremacy over ancient oceans. Tonight, we dive into the Miocene epoch to witness the reign of this colossal hunter. The Evolutionary Miracle. 59 million years ago, tropical forests blanketed South Asia with dense, humid greenery. Rivers carved through the landscape, their banks teeming with life both familiar and strange. Among the creatures inhabiting these waterways was Indohyus, a mammal no larger than a modern house cat. With delicate legs and a slender build, it resembled a tiny deer or oversized rodent. Yet this unassuming animal held within its lineage the blueprint for something extraordinary. Indohyus spent much of its time near water, feeding on aquatic plants and small invertebrates. Its bones were unusually dense, helping it stay submerged while forging along riverbeds. This adaptation, seemingly minor, would echo through millions of years of evolution. The descendants of creatures like Indohyus would gradually spend more time in water than on land. Their bodies would transform in ways that seem almost impossible. Over the next 15 million years, evolution sculpted these early mammals into increasingly aquatic forms. Ambulocetus emerged around 49 million years ago, a creature caught between two worlds. Its name means walking whale, and it lived up to that description perfectly. With powerful limbs capable of both swimming and walking, it hunted in shallow coastal waters. Its long snout and sharp teeth made it a formidable predator of fish and smaller marine animals. But evolution was far from finished with this lineage. As millions of years passed, the descendants of Ambulocetus ventured deeper into the oceans. Their hind limbs shrank and eventually disappeared, becoming vestigial remnants hidden within their bodies. Forelimbs transformed into flippers for steering and balance. Tails developed powerful flukes for propulsion through water. Nostrils migrated to the tops of their heads, becoming blowholes that allowed breathing without surfacing completely. By 40 million years ago, fully aquatic whales swam through Earth's oceans. The basilosaurids represented this new era of marine dominance. These serpentine predators stretched up to 18 meters long, their elongated bodies cutting through water with deadly efficiency. They hunted sharks, smaller whales, and marine mammals, establishing themselves as apex predators. The transformation from land-dwelling hoofed mammal to oceanic hunter was complete. But the story of whale evolution was only beginning. Around 34 million years ago, the whale lineage split into two distinct groups. Baleen whales evolved filter feeding systems, straining tiny organisms from vast quantities of seawater. Toothed whales, however, retained their predatory nature, developing echolocation and sophisticated hunting strategies. Among the toothed whales, sperm whales emerged as some of the most remarkable. Modern sperm whales dive to crushing depths exceeding 2,000 meters, hunting giant squid in absolute darkness. They are the largest toothed predators alive today, with males reaching 19 meters and weighing up to 57 tons. Their massive heads contain spermaceti organs that may help with buoyancy control and echolocation. But millions of years ago, their ancestors took a different evolutionary path, one that led to Livyatan. Anatomy of a killer. The Miocene epoch, spanning from 23 to 5 million years ago, was a time of remarkable diversity. Oceans teemed with life in forms both familiar and alien to modern eyes. It was during the Tortonian stage, around 9.9 million years ago, that Livyatan Melvillei ruled the seas. This was not the deep-diving squid hunter we know today, but something far more terrifying. Livyatan stretched approximately 17.5 meters from snout to tail, slightly smaller than modern sperm whales. But size alone does not tell the full story of this predator. Its skull, over 3 meters long, was shorter and more robust than its modern relatives. The snout was powerfully built, designed to withstand tremendous forces. The jaws were proportionally stronger, supported by massive muscles that could deliver devastating bites. Inside that enormous mouth lay weapons unlike anything in the modern ocean. Conical teeth, the largest biting teeth ever discovered in the fossil record, lined both upper and lower jaws. Each tooth could exceed 36 centimeters in length, deeply rooted in bone for maximum strength. Unlike modern sperm whales, which have functional teeth only in the lower jaw, Livyatan's teeth interlocked when it closed its mouth. This created a cage of bone-crushing power capable of gripping, tearing, and shearing flesh from the largest prey. The skull's construction reveals the immense forces this animal could generate. Massive temporal fossae, depressions in the skull where jaw muscles attached, indicate extraordinary biting power. The zygomatic arches, bone structures supporting the jaw, were thick and robust. Every aspect of Livyatan's skull was engineered for one purpose: killing large, powerful vertebrates. Unfortunately, most of Livyatan's skeleton remains unknown, buried in sediments yet to be discovered. Scientists must reconstruct its body by comparing the known skull to those of extinct and modern sperm whales. These comparisons suggest a powerful, muscular body covered in thick blubber for energy storage and insulation. Strong tail flukes provided propulsion, while pectoral fins offered steering and stability. The overall picture is of an ambush predator built for strength and endurance. Livyatan likely possessed the efficient respiratory system characteristic of modern sperm whales, allowing extended dives. Its body was streamlined for speed when needed, yet powerful enough to overpower prey nearly as large as itself. This was not a scavenger or opportunistic feeder, but a specialized hunter of megafauna. Discovery and revelation. The Pisco Formation of Peru is a paleontologist's dream, a desert landscape hiding treasures from ancient seas. Sediments deposited millions of years ago now lie exposed, weathered by wind and sun. In 2008, an international team of researchers from the Netherlands, Peru, and Belgium were conducting fieldwork in this remarkable region. What they discovered would reshape our understanding of prehistoric oceans. Fragments of bone protruded from the desert sediments, weathered but unmistakably massive. As the team carefully excavated the site, they uncovered a remarkably well-preserved sperm whale skull. But this was no ordinary fossil. Enormous teeth, still embedded in the jaws, told a story of predation on a scale unknown in modern seas. The fossils were transported to the Museo de Historia Natural in Lima for preparation and detailed study. As paleontologists cleaned away millions of years of sediment, the true nature of their discovery became clear. The teeth were thick, sharply pointed, and deeply rooted, weapons designed for killing large prey. This was fundamentally different from modern sperm whales, which use their reduced lower teeth only for gripping soft-bodied squid. The researchers initially named their discovery Livyatan Melvillei, honoring both the biblical sea monster and Herman Melville, author of Moby Dick. However, the genus name Livyatan was already in use for another animal. Following scientific naming conventions, they changed it to Livyatan using the Hebrew spelling. The species name Melvillei was retained, forever linking this ancient predator to literature's most famous whale. The holotype skull remains the primary specimen for studying Livyatan. Though no complete skeleton has been found, the skull and teeth alone revolutionized our understanding of ancient marine ecosystems. They proved that large predatory whales once filled ecological roles similar to gigantic sharks. The discovery raised fascinating questions about competition, coexistence, and the dynamics of Miocene oceans. Hunting the giants. Livyatan occupied the apex of its food chain, a position earned through power and specialization. Its diet likely consisted of large marine mammals, including early baleen whales, seals, dolphins, and smaller toothed whales. The Miocene oceans were filled with cetacean diversity, many species much smaller than Livyatan. These made ideal prey for a predator equipped with bone-crushing jaws. Unlike modern sperm whales, which primarily hunt squid in the deep ocean, Livyatan targeted large, muscular, fast-moving vertebrates. Its hunting strategy probably relied on ambush tactics combined with overwhelming force. With its massive skull and powerful neck muscles, it could ram prey or seize them directly with its jaws. Once those interlocking teeth clamped down, escape would have been virtually impossible. The teeth themselves were perfectly designed for their purpose. Their conical shape allowed deep penetration into flesh, while their deep roots prevented them from breaking or dislodging during struggles. The interlocking arrangement of upper and lower teeth created a shearing mechanism that could tear through blubber, muscle, and bone. A single bite from Livyatan could inflict catastrophic damage on even the largest prey. Livyatan likely possessed echolocation abilities similar to modern sperm whales, using sound to navigate and detect prey. This would have allowed hunting at various depths and in murky waters where vision was limited. The ability to see with sound gave Livyatan a tremendous advantage, allowing it to track prey movements and coordinate attacks with precision. But Livyatan was not the only apex predator in Miocene seas. Otodus Megalodon, the legendary megashark, hunted the same waters. Reaching lengths of 15 to 18 meters, Megalodon possessed serrated teeth designed for slicing through flesh. These two giants occupied similar ecological niches, both targeting large marine vertebrates. Competition was inevitable. Direct evidence of conflict between Livyatan and Megalodon does not exist in the fossil record. However, their overlapping ranges and prey preferences suggest encounters were possible, perhaps even common. A confrontation between a full-grown Livyatan and a full-grown Megalodon would have been a clash of titans. The outcome would have depended on size, age, health, and circumstance. Despite this rivalry, the Miocene oceans were productive enough to support both predators for millions of years. Their coexistence shaped the evolution of prey species, driving them to become faster, more vigilant, and more evasive. Livyatan, with its intelligence and raw power, was a key force maintaining the balance of this ancient ecosystem. The ancient seas. The Pisco Formation preserves a snapshot of Miocene marine life in extraordinary detail. Shallow, coastal waters gradually transitioned into open ocean, creating a mosaic of habitats. This environmental diversity supported a rich and complex ecosystem unlike anything in modern seas. The waters teemed with life at every level. Baleen whales, ancestors of modern giants, filtered vast quantities of plankton. Smaller toothed whales hunted fish and squid in coordinated groups. Dolphins darted through the water with acrobatic grace. Seals hauled out on rocky shores, while seabirds nested in massive colonies along coastal cliffs. Among the seabirds were several species of spheniscus penguins, including the massive Spheniscus megaramphus. This giant penguin possessed a broad, powerful beak capable of capturing and crushing large fish. Other seabirds included boobies, cormorants, and the enormous pelagornis, a pelagornithid with a wingspan exceeding 6 meters. These bony-toothed birds soared over the oceans, their tooth-like projections lining their beaks for gripping slippery prey. Beneath the surface, the ocean was alive with fish, rays, and numerous shark species. Swordfish sliced through schools of smaller fish, while rays glided along the seafloor. Among the sharks, Otodus Megalodon reigned supreme, its massive jaws capable of crushing whale bones. The presence of both Megalodon and Livyatan created a dynamic ecosystem where even the largest animals face predation. Smaller toothed whales, such as Kogia and other sperm whale relatives, occupied less competitive niches. They hunted smaller prey in shallower waters, avoiding direct competition with the giants. Larger baleen whales, however, could not escape notice. Their size made them potential prey for both Livyatan and Megalodon, especially juveniles or weakened individuals. On land, the ecosystem was equally diverse. Pinnipeds patrolled beaches, their evolution from terrestrial carnivores still relatively recent. Semi-aquatic sloths, such as Thalassocnus, fed on marine vegetation near the shoreline. These unusual sloths had dense bones to remain submerged while feeding, using their broad snouts to grasp seaweed. Their presence demonstrates the ecological complexity of the Pisco Formation. Livyatan's fossils have been found beyond Peru, suggesting a nearly global distribution. Teeth attributed to Livyatan have been discovered in Chile, Argentina, South Africa, Australia, and possibly California. This wide distribution indicates that Livyatan ruled oceans across much of the southern hemisphere and potentially beyond. Wherever large prey was abundant, Livyatan thrived. The end of an era. Livyatan thrived during the late Miocene and early Pliocene, a reign lasting approximately 5 million years. But like all apex predators, its survival depended on the health of the entire ecosystem. As the Pliocene progressed, environmental changes began to reshape the oceans in ways that would prove catastrophic for specialized predators. Global cooling events altered ocean circulation patterns and reduced the productivity of certain marine regions. The diversity and abundance of baleen whales, Livyatan's primary prey, began to decline. As food sources dwindled, Livyatan populations faced increasing pressure. Specialized predators are particularly vulnerable to environmental changes because they cannot easily switch to alternative prey. By the end of the early Pliocene, around 5 million years ago, Livyatan disappeared from the fossil record. The exact cause of its extinction remains uncertain, but the decline of large prey species was likely a major factor. Without sufficient food, populations would have dwindled, eventually falling below sustainable levels. Livyatan's extinction left an ecological void in the oceans. Other predators, including orcas and large sharks, eventually filled some of these niches. Modern orcas, in particular, hunt large marine mammals using sophisticated cooperative strategies. In some ways, they occupy a role similar to Livyatan, though they are smaller and hunt in groups rather than as solitary predators. The disappearance of Livyatan also coincided with changes in the Megalodon population. Though Megalodon persisted for several million years after Livyatan's extinction, it too eventually vanished. The late Pliocene and Pleistocene saw continued cooling and changes in ocean productivity. The age of giant marine predators was coming to an end. Livyatan Melvillei stands as one of the most formidable predators ever to inhabit Earth's oceans. Its massive teeth and powerful jaws represent the pinnacle of cetacean predatory evolution. Though extinct for 5 million years, its fossils continue to reveal the incredible diversity of ancient seas. The story of Livyatan reminds us that dominance is temporary, that even the mightiest predators are vulnerable to environmental change. Yet its legacy endures, written in stone, inspiring wonder across the ages.